start after one. Okay, ma'am, start.
Okay. A very good afternoon to all my dear participants. Today we have with us Dr. Binita Rani, Professor and Head, Sanjay Gandhi Institute of Dairy Technology, Basu, Patna. On behalf of Organizing Committee member, I welcome our respected Dr. Binita Rani ma'am. Welcome ma'am. She has completed her BSc from RAU Pusa in 1988, MSc and PhD in Food and Nutrition from HAU Hisar. She is the recipient of Merit Scholarship and UNDP Fellowship, and also she got UNDP Fellowship during her PhD. In 1997, she got an opportunity to serve for farmer community of Ambala district in the capacity of training associate, KBK Ambala, and continued till 2001. In 2001, she was selected as training associate in KBK Patna, RAU Pusa, Samastipur. And after that, she has got transferred to Sanjay Gandhi Institute of Dairy Technology, Patna in September 2002. And then after, she got promoted as assistant professor in July 2005 and transferred back to KVK Patna in May 2006. She was also served as a program coordinator of KVK Patna in April 2012. And in January 2017, she was transferred to Sanjay Gandhi Institute of Dairy Technology, Patna. Now she is working as an head of the Department of Dairy Chemistry Department, Sanjay Gandhi Institute of Dairy Technology. She has honored with 8 awards in different national and international conferences. And she got 2 Best KVK Scientist Award, 3 Best Paper Presentation Award, Best Poster Presentation Award, Award for Outstanding Scientist, and Excellence in Teaching Award. And she has published around 2 books, 3 book chapters, 45 review research articles, 27 popular articles, 59 technical bulletins, and delivered more than 29 review and TV talks. Okay, with this word, madam, I welcome you, ma'am. Now, over to you, Binita, ma'am. Ma'am, you can start. Binita, ma'am, please unmute yourself. Binita, ma'am.
Thank you, Dr. Anuradha. So, friends, all of us are well aware of the fact that quality of our health depends solely on what we eat, especially how much pure form of food we are taking influences our physiological conditions. There are many factors which influences the purity of food we consume. Contaminants and adulterants may gain entry via many routes in a food chain, which may be intentional or unintentional. Our day starts with milk, and it is an important part of our diet, especially in the diet of children, and therefore it is very crucial that milk should be consumed in its purest form. But unfortunately, many dishonest businessmen and middlemen adulterate milk for getting huge profit, which is totally unacceptable by the society. Many adulterants which are commonly being added to milk includes water, hydrogen peroxide, salicylic acid, benzoic acid, neutralizers, melamine, formaldehyde, and the list is ever increasing. So, it is very important to have knowledge of detection of common preservatives and adulterants in milk to stay healthy and how to detect these preservatives. Friends, all of us know the definition of milk. It is normal mammary secretion derived from complete milking of healthy milk animal without either addition thereto or extraction therefrom, unless otherwise provided, and it shall be free from cholesterol. Obviously, milk is considered as almost an ideal food because of its high nutritive value, as it provides maximum types of minerals, bodybuilding proteins, health giving vitamins, furnishes energy giving lactose as well as fat in an easily digestible and assimilable form. Thus, milk is highly valuable food. Some malpractice is done by adding cheaper and resembling substances to milk or removing valuable components from it in order to make extra profit. This misconduct is called adulteration, and the added substance is obviously called adulterants. As per PFA rule, adulterant means any material which is or could be employed for the purposes of adulteration for gaining money. Now let us see the concept of adulteration. An article of food is considered to be adulterated if the article sold by a vendor is not of the nature, substance, or quality demanded by the purchaser and is to his prejudice, or is not of the nature, substance, or quality which it purports or is represented to be. Next, if the article contains any other substance which affects, or if the article is so processed as to affect injuriously the nature, substance, and quality thereof, if any inferior or cheaper substance has been substituted wholly or in part for the article so as to affect injuriously the nature, substance, or quality thereof, if the article had been prepared, packed, or kept under unsanitary conditions whereby it has become contaminated and obviously injurious to health, if the article consists wholly or in part of any putrid, rotten, decomposed, or diseased animal or vegetable substance, or is insect infested, or is otherwise unfit for human consumption. If the article contains any type of poisonous or other ingredient which renders it injurious to health, if the container of the article is composed, whether wholly or in part, of any poisonous substance which renders its content injurious to health, if any coloring matter other than that prescribed in respect thereof is present in the article, or if the amounts of the prescribed coloring matter which is present in the article are not within the prescribed limits of variability, if the article contains any prohibited preservative or even permitted preservative in excess of the prescribed limits, it will be treated as adulterants. If the quality or purity of the article falls below the prescribed standard, or its constituents are present in quantities not within the prescribed limits of variability, but which renders it injurious to health. Finally, anything added which is not basic composition of milk is treated as adulteration. So, sale of certain admixture is prohibited in case of milk which contains added water, selling skimmed milk as whole milk, dahi or curd not made out of milk means totally adulterated, milk or milk products containing constituents other than of milk. So, in broader sense, adulteration has been divided into two main classes. One is intentional adulteration, and second is unintentional. Addition of extraneous water, especially pond water, as it is heavier as compared to tap water, non-dairy proteins, melamine, urea, constitutive milk, animal fat, synthetic milk, etc. comes under the umbrella of intentional adulteration, and any sort of negligence, ignorance, or by natural means, natural entry of antibiotics into milk from cattle treated for mastitis, or uh, addition or natural entry of any type of pesticide, insecticide, etc. into milk comes under the heading of unintentional adulteration. So, we must discuss first of all about the purpose of adulteration. Why these middlemen or vendors are interested in adulteration? First is
Ma'am,
to
excuse me, ma'am.
fetch money. And most important or most easily adulterated food product which is required, which is added in milk is diluent, especially water and other adulterants, synthetic milk, surfactant, etc. And in case of use of diluents, obviously other things will be required to meet composition of milk. For example, to increase shelf life of milk, as milk is very nutritious, but its demerit, most important demerit is its shorter shelf life, even at room temperature. And to increase its shelf life, normally farmers are
Ma'am,
using
excuse me,
addition of
ma'am. Vinita, ma'am.
formaldehyde, hydrogen peroxide, or
Uh,
salicylic acid. When
Dear
milk
participants,
is
please mute yourself.
diluted, then for maintaining protein content, mostly urea or melamine is mixed as adulterant. In case of maintaining fat content, vegetable oils, animal fat, or detergents are added to milk as adulterants. So basically, common milk adulterants include varieties of carbohydrates, salts and fertilizers, neutralizers, oil and paints, detergent, pond water, as well as various types of preservative in order to combat developed acidity and increase shelf life of the milk. In case of carbohydrates, especially sugar, glucose, starch, maltodextrin, etc., are added in milk to increase SNF as well as total solids. Even salts and fertilizers like urea, ammonium sulfate, potassium sulfate, ammoniacal fertilizers, and sodium chloride is added to increase SNF and total solids. Various types of neutralizers like sodium carbonate, sodium bicarbonate, sodium hydroxide, calcium hydroxide, etc. are mixed to the milk in order to neutralize developed acidity and to extend shelf life of the milk. Even detergents like liquid detergent and washing powder are mixed to emulsify and dissolve oil in water, giving a frothy solution, which is natural characteristic of milk. Varieties of oils and paints are also adulterated in milk. For example, vegetable fats and oils, mineral oil, white paint, etc. Pond water, being heavier than tap water, is preferred for adulteration into milk. Even various types of preservatives like hydrogen peroxide, formaldehyde, salicylic acid, etc., are used for preserving and extending the shelf life of milk. So these adulterants finally affect our health. Let us see the ill effects of some of these important adulterants found out in various samples. Water decreases the nutrient value of milk, which poses health risk, especially in infants who are sort of totally dependent on milk. Even contaminated water cause additional health problems. Starch has been reported to cause diarrhea due to undigested starch in the colon, and accumulation in the body may prove fatal for diabetic patients because it is having high glycemic index. Melamine, a source of nitrogen, is also responsible for kidney failure and even infant death if consumed on regular basis. Urea also has been found to overburden kidneys, can even cause kidney failure. Formaldehyde has been observed to increase chances of even cancer, and it also causes skin diseases and eye disorders. Hydrogen peroxide, when used, creates lots of problems in digestive gastritis and inflammation of the intestinal wall. Various detergents used may cause gastrointestinal and kidney complications, and it is one of the various causes for food poisoning. And adulteration with carbonates and bicarbonates disrupt hormone signals that regulate development and reproduction. So we have seen the ill effect of various types of adulterants which are commonly used for adulterating milk for getting money. Now we will discuss about various conventional methods for detection of adulteration of milk. First of all, we are going to discuss about detection of various types of neutralizers, namely sodium hydroxide, sodium carbonate, sodium bicarbonate, etc. And one of the most important tests is rosalic acid test. For that, 5 ml of ethanol is added to the milk sample, to which 2 to 3 drops of 0.1% of rosalic acid solution is added. And if milk is adulterated, then rose red color develops. You can see, depending upon various types of preservatives, color differ to some extent. Like there is a slightly pinkish color on addition of sodium hydroxide, more pinkish color by the addition in case of adulteration with sodium carbonate, and slightly brownish color with the addition when addition of sodium bicarbonate is done to milk, whereas normal or pure milk shows slightly yellowish color. Second test is to measure alkalinity of ash. For that, sample is ashed in muffle furnace, and after cooling, it is diluted with 10 ml of distilled water, and then titration is done with 0.1 and hydrochloric acid using phenolphthalein indicator. If the titer value is more than 1.2 ml, it indicates that there is adulteration of milk with neutralizer. Otherwise, milk is as such. There is no change in normal milk. Next comes detection of pond water, which is normally used in villages, in rural areas by vendors to increase the volume. For detection of adulteration with pond water, 2 to 3 drops of diphenylamine, which is of 2%, is put in the test tube, which is rinsed with milk sample, which is adulterated with pond water, and there is development of blue color if it is adulterated with pond water, whereas pure milk doesn't show change in color. Next comes detection of starch. For this, 1% iodine solution is added to the milk sample, and there is development of blue color in case of adulteration with starch, whereas pure sample gives slightly yellowish color. Next comes resorcinol test, which is done to detect addition of sugar as adulterant. For this, 1 ml concentration of hydrochloric acid and 0.1 gram resorcinol is added to the milk sample taken in a test tube. Then this test tube is put in boiling water bath, and after 5 minutes, if there is development of red color, it indicates that the milk is adulterated with sugar. Otherwise, pure milk shows slightly yellowish color. Next is Barfoed's test for detection of glucose addition in the milk. For this, sample is taken in a test tube, and 1 ml of Barfoed's reagent is added to the sample, and this is heated in boiling water bath. After cooling, 1 ml of phosphomolybdic acid reagent is added, and in case of adulteration with glucose, dark blue color is developed. Whereas in case of pure milk, which is not adulterated with glucose, there is development of only faint blue color. Next is detection of maltodextrin. For that, 0.05 and iodine solution is added to the milk sample, and there is development of chocolate red brown color, which shows the adulteration of milk with maltodextrin, whereas unadulterated milk is as such. It is not. There is not a change of color in pure milk. Next is addition of preservative, that is hydrogen peroxide, in the milk. For that, few drops of paraphenylene diamine hydrochloride solution is added to the milk sample, and blue color is developed, which shows adulteration of milk with hydrogen peroxide, whereas pure sample remains white. Next test for detection of hydrogen peroxide is with potassium iodide starch reagent. For this, 1 ml of potassium iodide starch reagent is added to the milk sample, and there is development of blue color, which shows the adulteration of milk with hydrogen peroxide. Otherwise, pure milk remains as such, that is white color. Next, detection for adulteration with formaldehyde includes addition of ferric chloride to the milk sample. After that, mixing 5 ml of concentrated sulfuric acid is added along the side of the tube, and there is development of purple color ring, which denotes the adulteration of milk with formaldehyde. Next comes detection of urea in milk. For that, 5 ml of 1.6% of para-dimethyl aminobenzaldehyde reagent is added to 5 ml of milk sample taken in the test tube, and there is development of dark yellow color if milk is adulterated with urea, whereas pure sample shows only slightly yellowish color. Next is detection of ammonium salt, for which 1 ml of Nessler's reagent is added to 5 ml of milk sample, and after mixing, there is development of grayish yellow color in the adulterated milk, whereas pure milk, which is unadulterated, is converted, or it shows only light gray color. Next one is detection of sulfate salt. For that, first of all, 10 ml of trichloroacetic acid solution is added to milk, and after coagulation of milk, it is filtered through water and filter paper 42, and then a few drops of barium chloride solution is added to 5 ml of filtrate. Then, if milk is adulterated with sulfate salt, there is development of white precipitate, which shows that the sample is adulterated. Otherwise, there is transparent color in pure milk. So these were conventional methods. Now we will discuss about various modern adulteration detection methods, developed methods, under which spectroscopic method is very important, which gives rapid analysis. It is easy to use. Minimum sample processing is required, and small sample volume is also required. It provides high sensitivity and specificity. For this, first one is UV visible spectroscopy, which is used for detection of melamine, which is added to milk in order to improve protein content, and microgildal method is not able to tell that whether melamine is added or not in the milk sample, as by microgildal method, we are assessing only nitrogen content, and melamine also provides nitrogen. And different is NIR spectroscopy. Near infrared spectroscopy is used for adulteration of water, urea, other species milk, non-milk fat, animal or vegetable proteins. So depending upon its wavelength range, it is used for adulteration of water as well as urea, sodium hydroxide, and detergent. MIR spectroscopy, that is mid-infrared spectroscopy, is used for detection of adulteration of melamine, urea, glucose, and tetracycline hydrochloride, whereas Fourier transform mid-infrared technique is spectroscopy technique is used to detect for detection of adulteration of water, urea, sugar, starch, salt, formalin, melamine, and tetracycline hydrochloride. One of the latest technique for recognizing adulteration is gold nanoparticles. With advances in science and technology, nanomaterials have made significant progress in food adulteration. It is high sensitivity identification of the type and amount of analytes and nanocomposites based on gold nanoparticles and quantum dots is used for adulteration of melamine in milk. It has been observed that formalin adulteration detection, which is done by tolerance reagent, in normal case, silver precipitation at ppm level is invisible to the naked eye. Even it can't be detected by UV visible spectroscopy. But when these nanoparticles are added with tolerance reagent, these colloidal nanoparticle solution is even detected by UV visible spectroscopy and even by naked eye because of this color development. So here we can see the depending upon the amount of formalin concentration, there is changes in color from from pink to yellow. So this pink color is when there is no adulteration with formaldehyde, whereas depending upon its concentration, that is from 100 ppm, 200 ppm, 250 ppm, 500 ppm, and 1000 ppm, to this 1000 ppm amount of adulteration, it shows completely yellowish color. So silver precipitation produced as a result of reaction of tolerance reagent with aldehyde deposited on gold nanoparticles changes original pink color to yellow. This can be visualized here in this slide. So now melamine detection. As all of us know very nicely that melamine is a high nitrogen compound. It is added to milk in order to increase the protein content, and undetected by commonly used Geldal method. Adding melamine to foods can cause serious illness or even death can be caused if it is consumed on regular basis for long duration. So various detection methods for melamine in milk includes gas chromatography, HPLC, HPLC-MS, capillary zone electrophoresis, LC-MS, and ELISA test. And for detection of melamine, even gold nanoparticle-based rapid kit has been developed, which can be easily used for detecting adulteration of milk with melamine. There is the limit, its a limit of detection is even 1 mg per liter of melamine in milk. Even this level can be detected by this method. Acid timing includes only 10 minutes, and this kit can be used up to 1 year after manufacturing. And most important thing in this case is developed color is visible to naked eye also, and it can be compared with standard colorimetric card without aid of any instrument. Here you can see at the level of without adulteration, this is completely pinkish in color, whereas there is change in color depending upon amount of melamine added to the milk from pink to gray. Next important methods used nowadays include immunological method, in which ELISA technique is very important. This is used for detection of addition of vegetable protein, whey, melamine in milk, and this is based on antibody-based analytical method to detect fraudulent addition of even 1 to 2% level of sweet whey in the milk. Next one is Western blot immunoassay analysis. Even for 0.5% of cheese whey adulteration, 1% of ovine and caprine cheese whey in bovine milk. Most important limitation of this method includes antibody development, chances of cross-reactivity, and prolonged washing procedure. Next is cryoscope or freezing point of milk, which is also important, as freezing point can be modified by using any type of adulterants which will bring change in density. So this is mainly used for adulteration of water in the milk. Alternate method, including Carl Fisher titration method, is also used for under cryoscope method. Next important method includes PCR method. It includes multiplex PCR as well as real-time PCR. It is based on amplification of species-specific DNA sequences. It differentiates between milk of different species when adulterated. Adulteration of bovine milk in ovine milk or caprine milk it identifies even lowest concentration, that is 0.1 to 1% of adulteration of bovine milk in caprine milk, detection of foreign protein in milk, and it quantifies and detects milk and milk products from buffalo, goat, and sheep. Next important method is chromatographic techniques, which includes reverse phase HPLC and HPLC-MS. Reverse phase HPLC includes the adulteration of milk with soya and whey protein, adulteration of skim milk powder with soya protein and pea protein, whereas HPLC mass spectroscopy method is used as routine detection of melamine and other nitrogen compounds like amylide, cyanuric acid, allantoin, thiourea, urea, biuret, triuret, semicarbazide, aminotriazole, cyanamide, guanidine, choline, hydroxyproline, nitrate, and a range of amino acids. Even adulteration of SMP with foreign protein can be diagnosed by this method. Next important method is biosensors. It is simple sample for this biosensor method. Simple sample treatment is required. It also takes very lesser runtime and detection of melamine in milk, urea, non-fat, non-milk fat, exogenous proteins, preservatives, whey, adulteration of cow milk in goat milk is found out by using this biosensor method. Next one is electromigration method. For this, electrophoresis is used for adulteration of even 1% bovine milk in caprine milk. Next includes SDS page. By this method, foreign protein in milk identify bovine whey protein in almost every bovine, caprine, or bovine ovine milk blend. Next one is capillary electrophoresis. By this method, adulteration of foreign protein in milk can be done. Adulteration of whey and casein protein in milk is also assayed, but its limitation includes poor reproducibility, low sample loading capacity, and longer analysis time. Next important method using nowadays include electronic tongue. This is new methodology and an alternative to the classical analytical method. It is developed rapidly in the last decade due to its potential use in the food quality control, emerging technology which combines sensor data fusion, pattern recognition, and computer technology. It is used to detect caprine milk adulterations with bovine milk. It is a simpler, faster, and economical procedure. And adulteration of cow ghee with sunflower oil or soybean oil or cow body fat can be recognized by using electronic tongue. Now let us discuss about few rapid tests for detection of common milk adulterants. Various kits have been developed by various institutes like NDRI, Gadwasu, and even High Media company has developed. So rapid test for detection of common milk adulterants, modified easy to carry kit was developed by NDRI Karnal for detection of neutralizers, starch, glucose, sugar, bond water, urea, salt, ammonium compounds, maltodextrin, H2O2, and formaldehyde in milk. For that, already mixed chemical is provided, which is used for detection of various types of adulterants after addition to the milk sample. Rapid paper strip based kit was also developed by NDRI Karnal for detection of neutralizers, urea, sucrose, H2O2, maltodextrin, etc. And the shelf life of this strip is 6 months at room temperature. For this method, prepared strip is dipped in the milk sample, and if it is adulterated, there will be change in color, which will tell about the detection of milk, about the adulteration of milk by that particular adulterant, depending upon development of that particular color. Even rapid test for detection of detergent in milk was developed by NDRA in Karnal. So by observing the developed color, we can come to know whether milk sample is adulterated with detergent or not. Next and very important method is 3D portable low-cost paper-based microfluidic device, which was developed by IIT Madras, and it can detect multiple adulterants simultaneously. Most important thing about this method is that multiple adulterant can be detected simultaneously in a liquid sample using a small volume of liquid sample, that is 1 to 2 ml only. Testing time is also less than 30 seconds, and limit of detection is 0.05 to 0.2%. Sample is added to the device through the hole in the top cover, and the liquid flow is caused by the porous paper substrates due to the inherent capillary action. This inherent capillary action, and at a time, various adulterants, namely urea, detergent, soap, starch, hydrogen peroxide, sodium hydrogen carbonate, and salt, can be simultaneously diagnosed in the milk if these adulteration has been done. Next one is multiple adulterant test strips, which was developed by DRDO. This is used for detecting adulterants, namely boric acid, detergent, hydrogen peroxide, neutralizer, soap, starch, and urea. Testing time is very small, that is only 5 minutes, and only 1 drop of sample volume is required. So at a time, these 7 adulteration can be diagnosed by this method. Next one is paper-based strip, which was developed for the detection of pesticide and antibiotic residues if present in milk, and that paper-based strip was developed by NDRI Karnal. NDDB has also developed the adulteration detection kit for the detection of ammonia, fertilizers, pond water, or nitrate fertilizers, which is already present in the pond water, urea, cereal flours, starch, glucose, sucrose, various types of neutralizers, H2O2, and salt. The kit is available in 3 sizes: small, medium, and large size, for detection of different number of adulterants. 2 different sized adulteration kits were also developed by High Media: milk adulteration kit for 11 adulterants and for detection of 6 adulterants. 11 adulterants including alizarin, formalin, urea, starch, neutralizers, detergent, sodium chloride, skim milk powder, sugar, glucose, and hydrogen peroxides, while smaller kit includes various chemicals for diagnosis of 6 adulterants, namely maltodextrin, cellulose, proteins, ammonium sulfate, pond water, and boric acid. 2 types of milk adulteration kits for identifying 5 adulterants and 10 different adulterants were also developed by College of Dairy Science and Technology, Gadwasu, including these different neutralizers, namely sugar neutralizer, urea, starch, hydrogen peroxide, ammonium compound, glucose, sodium chloride, nitrate, and formalin. So these 10 adulterants. Apart from these, various instruments have been also developed for easy detection of these adulterants. Indifos as well as Lactoscope 300 have developed these 2 instruments, which are based on Fourier transform infrared technology, and these are used for recognition or identification of adulterants, namely added water, urea, sucrose, maltodextrin, and ammonium sulfate present as adulterant in the milk sample. POS Milko scan has been also developed for diagnosis of hydroxyproline, sodium nitrite, melamine, maltodextrin, cyanuric acid, formaldehyde, sucrose, and sodium bicarbonate, whereas phosphamilcoscan has been developed based which work on the basis of Fourier transform infrared technology. It is used for presence of adulterants, namely urea, sucrose, formaldehyde, sodium bicarbonate, and potassium nitrate. So, friends, from today's discussion, it is clear that to retain nutritional sanctity and quality of milk, a number of milk adulterant testing methods are available, some of which are simple and rapid, but some are costly and also time consuming. So, depending upon the need, specific milk adulterant detection technique can be helpful in curbing the malpractices existing in the milk and dairy sector. And by using these detection techniques, we can identify if there is any type of adulterant added to the milk in order to secure our health. That's all. Thank you. Thank you very much. Any questions?
Thank you so much, ma'am, for the nice and informative session. Now the session is open for the discussion. Any participant, if you have any query, please ask. Dr. Anju, ma'am, please, you can ask your query directly by unmuting yourself. Dr. Anju, participants, if you who have raised your hand, please ask by unmuting yourself. Dr. Anju Bura, Dr. Rajeshwar, Dr. Kishore, or you can write in on the chat box also. Participants, if you have any query, please ask. Okay, ma'am, I think there is a no query. Hello.
हाँ मेरा कुछ सुनाई नहीं दे रहा है यहाँ तो मुझे भाई हाँ हो गया अच्छा
So if there is a no query, then on behalf of organizing committee member, ma'am, please ask if you have any query. Okay, I think if there is a no query, then whoever raised their hand, please ask. Okay. Hamida, ma'am. Hamida, ma'am, you are requested to please unmute the participants who wants to ask the query. Okay, Vinita, ma'am, is my voice audible to you? Please, participants, please wait. I think there is a issue in my laptop.
हेलो मतलब नहीं आ रही है वही तो बोल रहे हैं कि आ क्यों नहीं रहा हाँ तो आ ही नहीं रहा है मेरे लैपटॉप में मुझे समझ में नहीं आ रहा क्या करना है Actually, other things
Participants, if you actually there is some problem in this laptop, let me answer on my system. And there is a one question. Dr. Anjumura wants to ask to elaborate about the protein history. Protein history melamine question. I think someone to ask. Hello. Hello. Actually,
the whole done. Actually, for detection of melamine, that gold nanoparticle based rapid kit is used, not strip. आवाज ही तो नहीं आ रही, पता कैसे चलेगा?
Yes, ma'am, please explain. I think there is a problem. Dr. Anjupura, I want to add into this that she has explained about the adulteration kit of the melamine, which was based on the nanoparticle. Okay, and by using the spectrophotometer, you can detect on the basis of color differentiation, the concentration of the melamine can be easily detected by this kit. Okay, any other participants? Dr. Rajeshwar, please ask, please unmute yourself, or you can write in the chat box. Okay, I think there is a no query. On behalf of organizing committee member, I thank you, Dr. Binita Rani ma'am, for this nice and informative session. Thank you so much, ma'am. And thank you all the participants for their patience listening. Okay, participants, we will meet tomorrow session at 11 a.m. Thank you.